How to sketch a quadratic function given the function. So we know that in a quadratic function we have three important points. So if you have a quadratic function, so there are 3 points that are very important here. One is the vertex, these two the x-intercepts, and finally the y-intercepts. So these are the 3 important points in a quadratic curve: the vertex, the x-intercepts, and the y-intercepts. So for y-intercept, means where x is 0. As you can see, x is 0 here. So meaning substitute x as 0, you find y. Y here, substitute y as 0. Y equal to 0. Here, a quadratic function is always equal to y equals ax minus h all squared plus k. This hk is the vertex, coordinate of the vertex. So I'm saying that this is the vertex, the coordinate is h comma k. So that's it. So we need to get this. Well, the easiest ones to get is the x and y intercept. The vertex, we need to do some calculation, do some algebra. So, and again, generally, a quadratic function is given as y equal to ax squared plus bx plus c. So the y-intercept, c is always the y-intercept, yes, because if you substitute x equal to 0, we are left with c. And again, for this to have x-intercept, b squared minus 4ac must be either greater than or equal to 0 for the quadratic function to have x-intercepts. So that's the condition for quadratic function to have x-intercept. B squared minus 4ac must be greater than or equal to 0. That's real roots. So let's now, these two are easy, just substitute the value. The problem now is to get to ability to transform this to look like y equal to a bracket x minus h squared plus k. So that's what we are going to do. So we're going to do now. So how to find the vertex of a quadratic function from the function? So first of all, we need two concepts here. The first one, general form of a quadratic function. That is, for every quadratic function is always equal to y equals a x minus h all squared plus k, where h, coordinate hk, is the vertex. So we need to transform the function to look like this. So here is now hk is now the vertex, which is what we are looking for. So secondly, how to make a quadratic function, a perfect square. Because if you look at the general equation, here is a perfect square. So assuming you are given a quadratic function, ax squared plus bx, we always add we always add b squared over 4a to make it a perfect square. To make ax squared plus bs a perfect square. So as that's add b squared over 4a to ax squared plus or minus. This should be plus or minus. The result, once you add it, it will turn to a perfect square. And whatever that is in the bracket will be square root of ax squared, which is root ax, plus or minus square root of b squared over, that's square root of these two n values, which is b over 2 root a. So example, someone asks you what will be added to maybe 4x squared minus 2x to make it a perfect square. To make it a perfect square. So the answer will add, so my b here is minus 2, so I'll add minus 2 all squared over 4 times 4. So which is now 4x squared minus 2x plus 1 over 4. So we'll add 1 over 4 to make it a perfect square. And it will now turn to, as I'm just adding, the answer is 1 over 4. So it will turn to this. Square root of 4x squared is 2x minus square root of 1 over 4 is 1 over 2. So that's the perfect square now. Once you add 1 over 4, it will turn to this. So let's look at this question. That's the actual question now. We're asked to find the vertices of the following. So the first one, we need to add because I want to make x squared minus x a perfect square, so I'll add minus 1 because my b is minus 1 here over 4 times 1. I've added this, but remember we've changed the equation by adding that, so we need to subtract back to balance the equation, so that it will be like the original equation. So this minus this is 0. We are left with the original expression. So we've ended up making this a perfect square. This is now a perfect square. This x squared minus, and the result will now be square root of x squared is x. Square root of 1 over 4 is, remember it should be minus because minus is here, is 1 over 2 all squared. So plus 5 minus 1 over 4. So our answer is x minus 1 over 2 all squared plus 19 over 4. Yes, because from our general form of equation of quadratic curve is always, if you could remember, is always y equal to a x minus h squared plus k, where hk is the vertex. Therefore, the vertex is half, 19 over 4. So that's what we are looking for, the vertex of this. So why the second one? What I will do, I will first factor, I'll factor 2, which is 2 brackets. I have x squared minus 7 over 2x plus 1 over 2. So we now start the main thing, which is applying making this a perfect square. So we add minus 7 over 2 all squared over 4 times 1 to make it a perfect square, but we need to counter by subtracting again. Minus 7 over 2 all squared over 4 times 1. So we have 2 brackets. This is now a perfect square. X squared minus 7 over 2x plus this is a perfect square, and it will turn to square root of x squared is x. Square root of this, square root of 7 over 2. So it's, remember, it's minus because of this minus 7 over 4 all squared. So why this? We just expand. We open up. That's 49 over 16. So let's add up. We have 2 in bracket x minus 7 over 4 all squared plus half minus 49 over, that's 8 minus, it should be minus, okay. This is minus 41 over 16. So we still continue. So we have y equal to, we open up because we need to make it to look like this. Y equal to a times x minus h all square plus k. So we can compare, we open up. So 2 times this is 2 times x minus 7 over 4 all squared. Y 2 times this is minus 41 over 8. Okay. We now have our vertex. Therefore the vertex is 7 over 4. That's our h. And our k is minus 41 over 8. So that's what we are looking for. So whenever you are given this type of question, you need to check if the coefficient is 1 before we start the normal process. So since we've known how to find x-intercepts, y-intercepts, and the vertex, so let's now sketch this curve. Y equal to 2x squared minus x minus 1. So let's sketch this. So the first thing, let's get the y-intercept. So the y-intercept that is x is 0. So I substitute the value of x equal to 0. We see that y is 2 0 squared minus 0 minus 1. We have minus 1. So for x-intercepts, that is y equal to 0, we have, substitute y as 0, we now have 2x squared minus x minus 1 equal to 0. As you can see, this will have x-intercept, yes, because minus 1 squared minus 4 times 2 times minus 1. That should give us 9. So it's a positive value. So, and it's also a perfect square. So we now have that is factorizable. So we can factor this as 2x x, that's 2x 1 times x minus 1 equal to 0. So we can factor this, is factorizable. So from here we see that x is minus half and 1. So solving for x. So coming to find the vertex, so that's where we'll have to, so we'll factor 2. I have x squared minus x over 2 minus 1 over 2. So this is also 2 brackets. To make this a perfect square, I have to add minus 1 over 2 all squared over 4 times 1. But I need to counter it, so we need to subtract back minus, I'll expand. Let me expand further. Okay, let's just write minus 1 over 2 all squared over 4 times 1. So I had to subtract so that I will get back to the original equation. So that's it. Remember everything in the brackets. So we now have that y. So this is now a perfect square, which is square root of x squared is x minus square root of, that's 2, that's 1 over 16, which is 1 over 4 all squared minus half, so minus this is 1 over 4, that's 1 over 16. So I have y equal to, we can open up, we have 2 times x minus 1 over 4 all squared minus 1 over 2 minus 1 over 16 is minus 9 over 16. So minus 9 over 16, 2 times minus 9 over 16 is minus 9 over 8. So as you can see, we now have that which implies that the coordinate, the vertex, is 1 over 4 comma minus 9 over 8. So let's sketch the curve now. Okay, let's now sketch this curve with this information. Let me just draw. That's x, that's y, that's origin. So the curve will be like this. From what I'm saying, I have, so let me to go this way. Yes, where this is minus half, that's the x-intercept. X-intercept minus half 1, y-intercept minus 1. The vertex here is 1 over 4 comma minus 9 over 8. That's minus 1 point something. This is 1 over 4. That's closer to that. So this is my function. The function is y equal to, so let's write it in form of y equal to 2 bracket x minus 1 over 4 all squared minus 9 over 8, or maybe the original expression. So that's the curve. We've sketched the curve. Thank you.